Let's look at this Cartesian plane. This will be the x-axis. That will be the y-axis. X here will be negative. This part of the y-axis will be negative. So 1 here, 2 there, 3, 4, minus 1, minus 2, minus 3, the 1 here, the 2 there, the 3 up there, minus 1 here, minus 2, minus 3, and minus 4. We are going to have a look at the function y is 2x plus 2. Y is equal to 2x plus, let's say, 1. And we are going to start by tabulating throughout the domain and the range. This will be your x. That will be your y. Put 0 here. 1, 2, minus 1, minus 2. You can put minus 3 here. But you're only keen on the first 5 that is with here. We are going to substitute the value of x on that equation and realize what y is. Now, if I substitute x for a 0, it's going to be 2 times 0, which is a 0. 0 plus 1 is a 1. If I substitute for x being 1, when x is 1, that will be 2 plus 1. That will give you a 3. So when x is 1, y is a 3. Let's see what happens when x is a minus 1. Y will be 2, negative 1, plus 1. And negative 2, negative multiplied by positive is a negative. And then the signs are not the same here. We subtract and take the sign of a bigger number. The bigger number is 2. If we subtract 2 minus 1 is a 1. The bigger number is 2. That's minus 2. So when x is a minus 1, y is also a minus 1. Let's see, when y is a minus 2, y will be 2 minus 2 plus 1. This will be negative 4 plus 1. That will be negative 3. That will be negative 3. And when x is a 2, 2 times 2 is a 4. 4 plus 1, that gives a 5. Now, we need to appreciate that when x is a minus 3, 2 times minus 6, minus 6 plus 1 is a minus 5. So, this we say x, when x is a 1, y is a 3, this is a coordinate. Now, if you write that, you can say when x is a 1, y is a 3. When x is a 0, y is a 1. That's how you write the coordinates. When x is a -3, y is a -5. Now we can plug in these coordinates onto the Cartesian plane. We say when x is 0, y is a 1. When x is a 1, y is a 3. When x is a -1, y is -1. Now we can continue putting all these other coordinates onto the Cartesian plane. And now you can just join the dots. When y is 0, let's see, let's just join, let's see. This is your function, that's your graph there. Now, continues that way. And then this can be written as y is 2x plus 1. That is your graph there. We are going to have a look at the very graph, but we will be using only 2 points to draw the graph. If you look at the Cartesian plane, of the -1 here, -2 and -3. 1 here, 3 there, 4 there, -1, -2, -3, -4. When you are given that y is 3x plus 2, we are going to use the x and the y intercept. One, for the x-intercept, we let y is equal to 0. 2, for the y-intercept, you put x equal to 0. Let's start with number 1 then. X-intercept, y is 0, that would be 0. That y there is 0. And then that will equal to 3x plus 2. I can transpose the 2. Negative 2x is equal to 3x. Negative 2 equal to 3x. We divide here by 3 because we are looking for x, not 3 of those x. So we have x is negative 2/3. Now, we said x gave us 2/3. When our y, we chose long time ago that our y is 0. There's a coordinate. Now let's go to number 2. The y-intercept. You let x equal to 0. There's your y there. Y 3, but you said your x is 0. Plus a 2. 3 times 0 is a 0. Plus a 2 there. That will be a 2. In a coordinate, we chose x 0. There's x there. Y is a 2. We can draw that x is 0, y is a 2, and x is negative 2/3, somewhere there. And we can join the dot, we can join now there goes your function. Goes up, goes down there. And this is y is equal to 3x plus 2. Now, on our standard form, we had y is equal to mx plus c. And we agree that c is the y-intercept. And our c here will be a 2. And we see that the graph passes the y-intercept at 2. And then that will be the slope changing y divided by changing x. This will be the change in y. And that will be a change in x. And this is the rise. And that will be the run. That will be the rise. That will be the run. This will give you a change in x. If you remember, we said the change in y is equal to y2 minus 1. The same thing here. Change in x will be x2 minus x1. And that gives you the slope of the function as is. We will look into other problem.